Okay, so this is tutorial for week 11, and the agenda I'm going to do today is on 3D Mohr circle and material property. So on Tuesday, we did 3D Mohr circle. We did the theory. I did just for example. Now I'm going to show another example, which is similar to your homework question. Okay. So I've uploaded this example on Avenue to Learn, so you can get this example also. Okay. So let me copy and paste this example. Then we go from there. Right. So this is a example on 3D Mohr circle. Okay. So what is given to us is we have a stress acting in the x direction in compression, 70 megapascal. We have a 40 megapascal shear. Okay. We are asked to determine the two values of stress y. Okay, so we have to determine the two values of stress y. So we are also given that the maximum shearing stress is 75 megapascal. Okay, so this is a 3D problem because you are looking at a 3D structure. So you have X, Y, and Z. So at the same time, what I've done, I've posted the solution from the solution manual, right? So this is the solution from the solution manual. Okay. So you will see there are a lot of equations. Okay. Even I look at them, I can get confused. Okay. And this solution is based on Mohr circle. Okay. So for someone to do a solution like this, you have to be able to visualize Mohr circle really well in 3D domain. Okay, but we can't do that. So what I'm going to do is I'm going to solve this problem using the technique that I've taught you. Okay, not forming equation like that. Okay, but by using what I taught you in 2D Mohr circle. But I'm going to superimpose the material strength. Yeah, I'm going to draw a bracket for the material strength. Okay, so let's start by looking at this problem first. Okay. So as I said, this is the solution. Okay, we will just use some numbers to check. Okay, from the solution manual to check is our numbers valid or not. Okay, but we will not solve it exactly the same way. Right. Okay. So given to us in this problem is where we have stress X is equal to minus 70 megapascal. We are given that shear XY is equal to shear YX, and this is equal to positive 40 megapascal. Whether positive or negative shear does not really matter at all. And we are given that stress Z is equal to 0 megapascal. Okay. So at the end of the day, we have to construct 3D Mohr circle for this problem, not just by doing 2D. Okay, we have to be able to solve 3D. Right. So now we are also given that tau max, and this is the condition. Okay, condition that have to be met is where tau max is equal to 75 megapascal. Okay, so theoretically, when they say tau max is equal to, so we have to make sure that our radius of the circle is 75 megapascal. Okay, right? So we start from here, and then I'm going to call this point. This is my point X, my point Y, and this is our point Z. Okay, right. So I'm going to go into the graph paper mode. Okay, so we are going to construct a Mohr circle, right? So we are going to go for, I'm going to draw the entire range. So it'll be a bit of laboring. So we're going to start from minus 200, 180, 160, 40, 12, 100, 80, 60, 40, minus 20, 0, 20, 40, 60, 80, 100, 120, and I'm going to stop here at 140. I'm going to start at 160. Okay, so that is our normal stress axis. Then we have our shearing stress. Okay, so we have our 20, 40, 60, 80. No point doing any further because the tau max is at 75. Okay, so minus 20, minus 40, minus 60, minus 80, right? And then shear stress element rotate clockwise, and then shear stress element rotate anti-clockwise. Okay, right. Now I'm going to draw the maximum shear onto Mohr circle first. I'm onto this diagram. Okay, onto this diagram. So we know that our Mohr circle cannot exit all this cannot exit this region. Okay, so I'm going to draw a box. So 75, and it's going to start at 150. Okay, so our Mohr circle, our 150, Eugene, hold on, I overshot, right? So our Mohr circle has to be contained within this box, okay, within this box, okay, within this red boundary that I have drew. So some of you might say, Eugene, why, right? Why you stop at plus minus 150? So if you look at our condition, okay, we know that stress Z is equal to 0. Okay, so our maximum stress is equal to twice the radius, right? And twice the radius is going to be plus 150 megapascal, okay, from point Z, which is 0. So the 0 megapascal is our anchor, right? Remember, this is 3D Mohr circle. This is not 2D, okay? And then our stress mean will be 2R, okay? And then it's minus 150. Sorry, why 150 is 2 multiplied by 75 times 10 to the power 6. Okay, so minus 150 megapascal from point Z. Okay, so I better write out the working for you guys. So that's where we drew our envelope, because at this line, this is our positive 150, right? This is our negative 150, and this is our negative 75, right? And this is our positive 75. So the 3D Mohr circle has to be within the red box. Okay, it cannot go outside. Okay, it cannot go outside. It cannot go outside the red box. If you go outside the red box, the material will yield. Okay, the material will go into plastic deformation if it's ductile material, or it might fracture if it's a brittle material. Okay, so we know that it cannot go out here. Okay, right. So let's look at the let's now find the possible y value. Okay, so we know the first point is at minus 70. So I'm going to draw our minus 70 line. Okay, so this is our minus 70 line. And the shear is going about in 40. Okay, the shear is going at 40. So remember what I told you about shear. Shear is rotation of the element. So you have to, does not matter is it positive or negative shear. It's all dependent on the rotation of the element. Okay. So we know that the first point X, the element is going to rotate anti-clockwise. So this is our point X. Okay. So we are going to find the other possible value of Y, right? So we know, I'm just going to sketch this out. Y will be basically from point X, okay? It will be somewhere that crosses, okay, that crosses the positive 40 line, okay? So now what we must do now is we have to find where the stress average is. Can you see? So where it intersects the normal stress line, okay, we have to find, okay, we have to find what is this point. Okay, we have to find what is it. But a good news is we know that the radius is equal to 75 times 10 to the power 6. So that's what's going to help us. Okay, so let me recap what I've just said. We have to find where is the stress average. Okay, and to find the stress average is not difficult because we have the radius. Right? We have the radius, right? We know where point X is. We have to find the stress average. From that, we can find stress average. Okay, so let's start doing that. So I'm going to do that. I'm going to get rid of this. Okay, so we're going to do that. Okay, so I'm going to call the distance. Okay, so the stress average. So I'm going to call this distance. Okay, so we know, right? Let me sketch this out again. We know, right? We know this is just a sketch, okay? It's not exactly this point. We know that this is our stress average, right? So we want to, we need to know this distance first. And this distance, I'm going to call it U. Okay, we are going to call U, right? So once we know U, right, we can find the stress average. In fact, the stress average can be in two locations, one on the left-hand side, and then the other one is on the right-hand side. Sorry, one on the right-hand side, the other one will be on the left-hand. So you can have two stress averages. Okay, you can have two stress averages. So the other one, you will have another stress average down here. Okay, so that's all. So we are going to find U. Okay, so as I said, this is a sketch. I'm going to get rid of the sketch again. Okay, so we're going to find U. So you now know what U we are trying to find. Okay, so U is equal to